All right, physics students, we're going to try something new here at the end of the semester just to see how it works. What I have here is the screen. I'm going to show you what you need to do for the circular motion simulation lab or the rotational lab, as you'll see in your worksheet there. And following this video will be a 5-question quiz. In order to begin working on the lab, you need to get 100% on the quiz. So um, here we go. You are going to go into modules. I'm in the module here, and you are going to go down to Circular Motion Simulation Lab and click on that. And let's click on the attachment that says Rotational Motion Web Quest. That's the name of the document. And it's going to open in Word for me. Don't know if it'll open in Word for you. Hopefully it'll work out. Okay. The first thing you're going to open is Motion 2D. And here is the link right here. And hopefully this will load. Not loading. Oh, there it is. All right, so hit run now, like always. And we have the max, so it should look pretty similar. And here we go. Okay. Up here, you are going to look at velocity acceleration. You're going to show both. And as you're looking down here, we are going to be looking at circular motion. So you're going to click on circular motion, and you are going to see both vectors there. As you click on more controls, you can change the velocity by dragging it. You can see which vector gets larger there. If you click acceleration, you can see which vector gets larger there. So time scale, by changing that, obviously now it changes the speed. Okay, so that's the first one we're going to be working with. Okay, we can go ahead and close that out. Go back to the module. So you're going to answer a few questions about motion in 2D. Okay, actually you're going to go back to the to this page here, and I don't care how you get on the website. You can just click on this or type it all in. It is a long thing to type. You are going to now click on this to go to the Ladybug Revolution site, which should be loading. Here it is. And you are going to click Run Now and go through that as usual. Takes a little bit to load, so be patient as always. So here we go. Here's the intro. We've clicked here to show velocity vector, clicked here to show acceleration vector. If I want to know how far this ladybug is from the center, in other words the radius, I click on ruler, and the ruler will show me. This is in meters, centimeters, right? So we look here and we see the ladybug is 2 centimeters from the center, right? 6 minus 4 is 2. Okay, and we can leave this ruler on here if I want to change the ladybug. Now it's 3. Now the ladybug is 1. Okay, but we'll put it back here to 2 centimeters. Okay, we have an angular velocity, which is 0, so it's not moving right now. And if I want to give it an angular velocity, in other words, how angles per second, right? So 360 degrees is a circle. So if it travels 360 degrees in 1 second, it's going to travel this entire circle in 1 second. Okay, so if we put this at 360 and hit enter, okay, 360 degrees per second. We pause, Okay, and we see the acceleration is pointed toward the center. We see the velocity is tangent. In other words, it is straight off from the edge of the circle. In other words, perpendicular to the radius is the tangent. Okay, but we'll be going much slower in our lab. I believe it's 90, if I'm not mistaken. And now you can see the smaller, let's remove the ruler, and we can see the smaller acceleration vector there and the velocity vector there. Notice they look very similar to our previous 2D page. Okay, let's go to the rotation. And we see all these graphs, and you're going to be like, Mr. Wilson, these are crazy. Okay, you're going to be answering the questions on there, and we can change the angular velocity. Okay, we can change the angle. If you go back to intro, we had the angular velocity there, degrees per second. That's all that little thing means. Okay, and then we have graphs. We have angle, the angle per time. Okay, we have the angular velocity, and then we have the position. Okay, so right now it says 2 meters away, just like it was before. We can always change it. Okay, here's the vector, here's the ruler, here's the sim speed, which you can slow it down. Okay, so if we put this at 90 once again, okay, we hit go. Okay, and now we're looking at the degrees are increasing. So it's 360 degrees, that's going to go off. Constant velocity, and now the position is constantly changing, right? It's going +1 to negative, looks like about -2, and as it's going up and down, you can see that. So the horizontal position and also the vertical position. If I stop it, okay, and now I can show a couple different things. I can show angular acceleration. Okay, if it's going constant velocity, it has a constant acceleration. Okay, now I can change the acceleration to 90. Oh, it didn't change. Okay, well, you guys are going to have to figure that out. I'm going to clear that. Now let's change it to 90 and see what happens. Nothing. Guess it needs velocity. So I'm going to have you guys figure that out. The other thing here is it has V. It has linear velocity, which was what we're really going to be studying this chapter. And it also has linear acceleration. Okay, so these buttons will change the graphs. We can show X acceleration. We can show Y acceleration, so on and so forth. So let's put this back at 90. Let's see what the acceleration is. For some reason it's not playing. Oh, I guess we'll have to hit go. There we go. I guess that was my mistake. Okay, so angle's already off the page. It's so high, but you can see constant velocity, constant acceleration. Okay, you can see the vectors there. So you guys are going to be answering the question about this. Here, these zoom in and zoom out of the graph. So if you want to look at more detail, you click on the plus and minus over here. Okay, so at this point, I want you to go to the quiz. I want you to answer 5 questions about what you just saw, and then you can go ahead and work on the simulation. Hope you guys have a lot of fun, and we'll talk to you later.